Good morning, folks. We are starting our very last section of these conic sections, and it's a little bit more familiar than the other ones probably have been thus far. So it sounds weird that we started parabolas back in chapter 2, uh, and now we're in chapter 9 revisiting parabolas, but we're going to revisit them in a very different way. Every section so far, we've covered them from kind of like a constructionist standpoint, where we were given some pieces of information about the object and then had to work with the equation to build the conic section. That's kind of what we're going to do with parabolas. So obviously we've seen parabolas before. You should know what the graph of that should be very familiar. There's going to be some new vocabulary associated with them in this particular section based on all of that constructing of the equation. So the official formal definition of a parabola is the set of all points on a plane that are equidistant from a fixed line and a point. So any point on this blue parabola we see, if I measure that to this red dotted line here, and we call that the directrix, versus measuring to the focus, this point here, those two distances are always going to be the same. So the directrix I already hinted at is a fixed line in that definition. So this horizontal line here in the equation, that's called the directrix. Notice it doesn't actually intersect the parabola. They don't touch, they never will touch. Okay, so that's rule number one about directrices, is they will never hit the parabola. Secondly, we have that focus, which is the fixed point that we talked about in the definition, and that is also inside of the curve of your parabola. Kind of like what we saw foci on a hyperbola do, they're always inside the curve. Now, this focus is p units away from my vertex, and the directrix at its closest point is also p units away. So they're going to be just as far from the curve as they are from the vertex. So that last width that we call kind of has a silly name. It's called the latus rectum. That's left over from some Greek influence in mathematics. I like to call it the focal width because it's literally how far to open the parabola at the focus. So the latus rectum is how wide the parabola is at the focus point. Now, all of these definitions have this P mentioned in it. The P is part of your standard form equation. Kind of like we saw A and B and C in the other equations. This one only has one, it's just P, and we have two standard form equations. So we have one for vertical parabolas, which are very familiar to everybody here. It's when they open up or they open down, okay? They are no longer going to be ax squared plus bx plus c. So they're going to be a little bit different based on the definition and how to find all of these. So this is your vertical standard form equation. Two things to note. X is being squared, and we have an HK. This is very similar to vertex form. If you can think way back to chapter 2, vertex form of a parabola has the H and K kind of highlighted it, and I think we even called it H and K back in chapter 2. Well, no surprise, HK is your vertex. Now, your textbook is going to focus on this form. I tend to prefer the second equation here because it kind of isolates and keeps the y minus k off to the side, and we've been working with y minus k all this long. Pick one, work with it. I don't have a preference which one you use. So in this, I already mentioned the vertex is hk. We no longer have a center, but you can kind of think about the vertex of a parabola as the center. We have an axis of symmetry. That should be nothing new. The axis of symmetry, if it's a vertical parabola, the axis of symmetry goes right perpendicular through your vertex. It's a vertical line, hence x equals the x coordinate of your vertex. X equals h. Your focus, if I am opening upward, it's going to be adding the value p to k. So this focus is always going to be above or below your vertex. A nice way to think about it is your focus is always on the axis of symmetry, and it's always inside the curve, and your focus is always p units away from the vertex. So you're going to always be adding p to some number. Now, this next part, directrix, is the new word. We haven't seen this word yet. And again, that's the line that is part of our definition of a parabola. So this, if it is a vertical parabola, meaning it's opening up or opening down, the directrix is going to be a horizontal line. And again, it's p units away from the vertex. So y equal to k minus p. It's in the other direction as the focus. Now, one quick thing is it does open up or down. P can be a negative number. So if P is negative, this would be a downward facing parabola. Just think about it from chapter 2. If I had a negative coefficient, it would look like a reflection occurred. So even though we're adding and subtracting here, keep in mind we might be adding a negative value to K. We might be subtracting a negative value to K in those two equations. So it all comes down to the value of P and if it is positive or negative. And of course, these rules, I'm going to go a little bit quicker for horizontal because they're very similar. So this time you notice a horizontal, it's the y is being squared. So if I see a y squared term, automatically I know it's horizontal. If the coefficient on that is positive, I know it's going to open to the right. And if P is negative, it's going to open to the left. And of course, HK is still that vertex. So the vertex stays the same. Your axis of symmetry, that's going to be a line through the vertex. That should make sense that it's going to be horizontal if it's opening to the left or right. So it's a y coordinate. Your focus and your directrix this time, we're going to go to the left and to the right of the vertex to identify my focus and my directrix. And again, because I'm horizontal, the directrix will be vertical. And again, I mentioned this already, but if P is negative, we are opening to the left. It's a curving to the left parabola. And if P is positive, we're going to open to the right. So let's get through one, maybe two examples for time's sake. Here is a very simple equation of a parabola. In fact, this is something you probably could have graphed in the marking period 1 when we covered quadratic equations. So again, friendly reminder, here's the standard form for a horizontal parabola. I know it's, vertical parabola, misspoke there, vertical parabola. And I know it's vertical because the x is being squared, okay? So there's no addition or subtraction anywhere evident in this equation. So that means our h and our k are definitively 0. And here's where it gets a little bit tricky. So if I'm looking for the value p, I should probably figure out the value p in order to get my focus, in order to get my directrix, in order to get a lot of the stuff. It all comes down to the same letter p. So if it's in standard form, notice your coefficient here is 1 over 4p. So I'm going to set 1 over 4p to whatever my coefficient is in standard form, which is what we're seeing down here. And then we're going to cross multiply and we can figure out the value p. So cross multiply, divide, solve, you get p equals -3, which because it's negative, obviously we know already that because of the negative coefficient, it's opening down. So I'm going to go below the vertex to find my focus. Even though it says adding p, I'm adding a negative number. So my focus is at 0, -3. My directrix would be above the vertex, okay? So I'm subtracting the negative number and I add the 3 to it. So it's a horizontal line, y equals 3 as my directrix. Okay, let's see another one. So again, we see that we have a standard form equation already presented to us, all right? We are able to isolate the x if you so choose. So if we do that, we can very quickly get h and k in this form is -2 and +3. This 2, when I subtract it over, becomes the -2, which is my h. K is 3 inside my quantity. Now, I know because it's the y coordinate being squared, this has to be a vertical, excuse me, I misspoke again, a horizontal parabola. Y squared makes it horizontal. So again, we go back to standard form. So I'm going to take this coefficient from standard form, whatever's in front of my squared term, I'm going to set that equal to 1 over 4p. Cross multiply once more, divide, you get p equal to be negative 1/8. Typically what happens is the larger the coefficient, the smaller the p value is going to be. So again, for a focus and a negative horizontal parabola, we know we need to go to the left of the vertex. So I'm going to be subtracting to the x coordinate. And I have this little improper fraction, but mixed number. An improper fraction would also be acceptable. If you want to give me negative 17/8, that would also work. The directrix would be to a vertical line, so I would expect to be an x equals number. And the directrix is going to be to the right of the vertex. That's why we're taking the x coordinate and subtracting a negative number. So we end up adding 1/8 to that x coordinate. So it's negative 1 and 7/8, or negative 15/8. Again, an improper fraction would be fine. Okay? So I'm going to cut it off there. We'll go through 1 or 2 more examples tomorrow. And definitely no more quizzing this week. We're probably going to have a quiz either Monday or Tuesday on these parabolas. I'm leaning toward Tuesday because I don't think Monday quizzes are great in any regard. But get started on the homework. Tomorrow's lesson will kind of help fill in the blanks with wherever you might be struggling. Of course, if you have questions, reach out. Good luck.